click the restart here. So I already installed the extension. So after you install the extension, it will show this under the radiotherapy or the module you need for the treatment planning system. Be remind that this synthesizer is a free software. Most a lot of other user also develop this extension. So there is a limitation compared to the real commercial remote planning system in the hospital. So for the next, I will show the first step to load patient image data. For this section, I will just use the sample data from the visualizer. So you can go to the this welcoming module and you can click the download sample data. For this session, I will use the CT chest. Just click CT chest and will download for you. So this is the view of the CT image. So this is the axial view, sagittal, and the coronal view. And this is the view of 3D model. And you can view the 3D model of your segmentation after the segmentation. And for this, you can adjust the window and the level scale to suit your view. You can click and drag above for the level and click and drag right to left for the adjusting the level. So for me, I think this is for the next is you can save. I think some of better for you to save every time you make a change, because sometimes this kind of the software, I think they use a lot of processing, and some of the usage RAM is very high. So maybe sometime it will crash. Better save, better be safe. Make sure you save, and you can change directory. Select your directory for change. Uh, uh, for the And if you want to load your own image, you can just click file add data. You can choose the what image you want. If you want to use the image, your own image, and this one DICOM browser is to import DICOM. So this is for the DICOM format. For the another format, you can use this function. Uh, If you want to save, this is the default format for the we use in the 3D slicer. So most of time I use uh, for my work I use MHD file or HDR file. I think the uh, you use what suitable for you. Okay, I think for the next we must go to the data module. You can choose the data here or just click here. So this is the image we load from the sample data. So before we start, we must convert to this patient image to the DICOM and create the new study for the. So we right click and click the export to the DICOM and just click OK. Because of DICOM, if you import DICOM, it will include all the patient data from You just click export to create new study. So just click export. Okay, and this is a new study. You can rename new study to whatever you want. Just double click. I rename to the TPS. So this is our new study, new patient. For the next step is contouring or segmentation. Click the module segment editor here, or you can go to right here and click the segment editor. In segment editor, you have to create a new volume segment volume, but I think it will automatic create it for you. You don't have a segment volume. So for the master volume, you use the city chest what you would load uh, from the previous. So so for contouring is you contour you define volume for the each organ. You can add the uh, segment volume here. Just click add and you can double click for rename. I think for usually case for for this study we will I will show you how um, to plan a treatment for external beam therapy for the esophageal cancer. But in this image, the patient don't have esophageal cancer. But because I I cannot find any patient that have esophageal cancer. But just I just this use this as a example. If for the salmon, usually we use uh, contouring for the volume need for the contouring include the first body, um, the OAR, lung, uh, heart for the esophageal. You can segment uh, all the organ, but I think better you just use the OAR segment for each for specific OAR for the case. Each case, different case, they have a specific OAR. So you for the beam planning, you have to insert the GTV, and the EV. Uh, for the contouring artifact, I assume you know the anatomical structure, the human body. And if you even you don't know, you just can you just can Google. I think it's more better. Okay, I will show you how to use the effect of for the segmentation. For the body, I will show you this is all the effect. For the um for I think the for the usually we use the pen to paint all the OAR we use. I think I will show you some of the more fast. So for the body, we just contour all the body. I use the effect of label tracing. We will automatically trace the outer level outer the body. So if you must have a steady hand to make this this okay. just click and it will automatic counter for you for this. So you have to counter every slice for this all the body. So I think I will show you other effect. This fill between slice. I think fill between slice is uh, also include in other commercial TPS, treatment planning system in hospital. So the fill between slice is effect. You can skip for this. You can skip for one or two, three slice and use this effect to fill for you, automatic fill for you. For example, I will show um, this. You can skip. I advise you just skip just a few slices because sometimes they can assume also they okay
Fahmi, there is a request. Can you light the mouse pointer? Maybe they cannot see your pointer. Is it possible for you to change the type of pointer that you're using?
no, I think I don't think it. Um, um, I cannot light on the pointer.
Okay.
Okay. Um, if, you can skip a few slides, so you don't need to counter all the slides. So just so you have to do from bottom to up. You don't need you you don't have to use only this Agile view, but you can also use this Sagittarius or Corona for the all the contouring. So I will show you how to fill between the slides. Click here. I already do some of the. So I will show you just a few, and you will do your in your own. And you click the this segment body, the effect of fill between slides. So you take click the initialize. Sometimes it will yeah, can show the 3D of the segmentation. So it will automatically fill the between the slides. So you just click apply. We show you the 3D model. For this you have to do from the top and from the bottom. And I think I will show you only that, and you will do because the contouring is really take a long time to contour all the body part. And for and before you do the next organ, you have to uh, this make sure this override of the segment is to not, because if you edit another organ, it will override the body. So this is really important. So make sure you click to the choose none. So we click the, if you want to edit this part, you have to click uh, and then you just edit. So if make sure also this one is you know what volume you edit. So for the LAN, I will show you how to use the threshold effect. Because of CT image, they have they call the Humphreys unit. They air, they have for material air, they have a sum of the value. For example, air is minus 100, 1000, about that range. So using this threshold, you can just counter some of the organ with the range of the HU value. So for this, we use the to counter line. So the line of mostly air. So the air also include in this region, but that's okay. I will show you how to remove the air outside the lung. So if you finalize with the threshold value, so just click apply and we counter for you. And for the just counter the just counter the lamp. We will use the island effect. Keep the selected island like the each region separate from the other region. So you can choose whatever region you want to keep. For this example, I want to keep the selected region. Region LAN. So I click the LAN. It will remove the outer air, air region. So this is we counter in the lab. So if you want to so if you want to view the 3D image of the lung, you just click the show 3D. I will show here. So this is the lung segment. And this is unfinished body. I think you can finish if you want. Later you want to try it later. For the next is heart and liver. I think this one is you better use the. You can click here to hide and to show the your content segmentation.
For me, can we stop for a while and then maybe ask if they have any question to ask for the body and heart that you have done?
Okay.
Any question
Any question?
from the participant? Can you follow for now?
Yes, I have two questions.
Sorry, who? Okay, yes, Joshua.
Hi, yeah, I'm Joshua. I have two questions. First, I'm just wondering is the level tracing in segmentation, does it trace the boundary?
Yeah. Yeah.
Okay.
We will trace the boundary based on SU value, I think. Because you can also use level tracing to trace the boundary of the soft tissue, but I think it's very complicated. But you have to have a steady hand to 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 trace the boundary of soft tissue. But soft tissue, because even for example liver, the soft tissue surround the, for example, intestine, in stomach, surround the liver also sometimes include in the liver tracing. So for example, I will show you the liver and liver tracing. Yes. So sometimes just it trace based on the HU value. So I think for the liver country and the heart, you should use the pain just manually contouring. So
Yeah, so it's
question, then that.
it's not automatic, is it?
Yeah. It is automatic.
Okay. My second question is, the contouring, can it just be done on the transverse, or can it be done on the other planes?
Any plane you want, axial, transverse, sagittal, and coronal. You can combine all the axial. If you can't see the axial, you can use the coronal and sagittal view.
Okay, thank you.
For me, there is one question. Can we use the threshold to automatically contour patient's body?
Yeah, you can do the threshold value for the contouring the threshold body, but you know the HU value for the lung also quite similar with the HU value with the air. So I will show you. So even the you can so this is the example. So some of the part in the lung also same as in the air. So I think uh, you can use it, but you have to feel the what cannot feel in the lung. You have to use other effect. I think the for better, I think you use the level tracing first and combine with the fill between slice. Okay. Okay. I think I will move to the next. For the heart and liver, you should use pain. And if you, but don't worry, I think this is effect you can learn by using YouTube, because this is a community. We have a large base of community to visualizer. So some of them upload how to use effect, grow from seed, very powerful effect. But bear in mind, I think should use with the, if you have a powerful laptop or PC, you can use this grow it on seed. You just counter a few slides and it will grow from the what you're countering. And I think you can learn from the tutorial from the YouTube for this, because I have to move uh, the country is take a lot of time to do, because I have to show you for the moving planning also. For this, I think I will show you what I have already done for the uh, in this because I want to skip time. So I think you can practice contouring by yourself after this. Uh, some some of the because of this synthesizer take a lot of processing power and take a lot of memory to operate. I think better you save every time you done something, because sometimes it will crash. I think it will take a lot of RAM resources, about sometimes about 2 GB RAM of slicer for slicer only. This is These are all the segmentation I already done for the you can show see the body. I counted all the body, the lung, heart, liver, and so um, in this example, I will show you on how to uh, increase the margin of the CTV, PTV, and PTV. So you know uh, the the meaning of the GTV is gross tumor volume is the gross the demonstrable clinical you can view the size of the tumor inside the using the CT image. So the actual volume of the tumor. So first you have to contouring the tumor. So for example, this one already contouring the esophagus, quite small. And for this one, I will show you how to increase the margin of the CTV and PTV because PTV is a clinical target volume. Clinical target volume is actually larger than the gross GTV because it will also include the subclinical malignant. Some of the cells surround the GTV also might have include the tumor cell. So this is volume is important. So and another volume is PTV. This is a planning target volume. I think some of you might already know the this volume kind of volume. So planning target volume is a concept of geometrical volume for the tumor planning system. This PTV is used for the planning for for the beam field. So usually the PTV and CTV actually the extend about 0.5 cm or 1 cm. It will depend on the oncologist. So some of them want 0.5 cm, 1.5 and 1.0 cm. Some of them it was depend on the oncologist doctor oncologist. So uh, wait, I will show you how to increase the margin to make sure this override frame is turned. So this I will show you how first because our CTV is don't it don't have the volume. So you need to copy GTV volume to the CTV. So you use the logical operator. You select the CTV you want to edit. So copy. I will use the operation copy to copy segment volume from the TV to the PTV, CTV. Just click apply. Let me show you already apply. So CTV and GTV have same size and same margin. So to increase, we use the margin effect. So we increase about I think 0.5 cm or 5 mm. So we apply. Expand the margin about 5 mm. So okay, you can click Control and scroll to zoom. So we show the margin increase. So for PTV also mostly 0.5 and 1 cm. I think we use 0.5 cm or 1.5 cm, 1.0 cm from the CTV. So I will copy also volume from the CTV. Right. So increase the margin about 5 mm. We apply. So this is how we use we apply for the yeah. This is to control the opacity. Okay, use this. Okay. After you finish all the contouring, the body, lung, heart, and the liver, all the OR, you satisfied with the all the segmentation. I think we should move to the external beam planning. So tip for you, if you have a no, I think for me slow very for me I have a slow laptop. So every time every time I contouring each organ, I here to unshow the 3D because sometimes every time you control it will show render to 3D and we 3D view. So some maybe it will show every time you control it. So better you to remove the 3D first before contouring. So show 3D on only for the after you finish and you satisfied. So sometimes it is sure it's not responding. Um, okay. I will move to the radiography in the beam planning. So
Fahmi. So maybe we ask have any questions for participant? We'll
okay.
proceed. Any questions from the participant? Okay, no question. We'll proceed now.
Okay, I will move to the beam planning. Um, after you install the extension CliSRT, the radiography column will appear and show you all the modules. You have to choose the external beam planning. First, you have to create the RT plan. So just create new initial one. For the reference volume, you have to choose the CT image you load for the previous. So just with the CT image structure from the segmentation. So click segmentation. Um, okay, that is so the for the point of interest isocenter same as isocenter. You want to move the target to the PTV. So just click target volume segment to the PTV and it will automatically move the isocenter to the PTV. So this is center. Uh, you can also move the isocenter manually. Just untick this one and you can drag the isocenter where you want to. This uh, this feature is important when you want to to I mean to rearrange your beam after you see the DBH is not certified. So you can use this ISO center to reduce the ISO center, move the ISO center, and for the next is add the beam. Okay. So for the beam, you can rename the beam. So you can edit the beam uh, for this kind of beam. This is the first beam we create. You can see the beam at the 3D view. For the source to distance, usually we use the 100 cm or 1000 mm. So make sure this you know the unit. So for the you can decrease the target volume, target field to the focus on the target ATV. Okay. So you can scroll down to make sure the all the organ is covered by the beam. So I think this one is okay. So you can adjust the gantry angle, collimator angle. For the first beam, I think just on the AP beam. The for the if you want to create another beam, just switch to the parent plane and add another beam. Or you can clone the beam. I think I will clone the beam. Just click the clone beam. Edit. I want to create same beam but with the different angle, with the different position. So source to distance is same 100 cm, and the second beam and adjust the size. So and for the next beam, I will move the gantry angle to the 180 degree. So and you can decrease the size of the beam. Okay, you go to make sure the target is in the cover by the beam. So this cover, I think you can proceed to next beam. You can add or more than for this one. I think I want to avoid the OAR. For example, the heart, to reduce the dose to the heart. And for the if you want if you create the multiple beam, you can adjust the beam weight. So each for me I will use the one. So all the beam have the same the intensity. So for this one I will use the scale size of the So okay, so same using the 100 cm force distance. So for example, this one is angle 110, and I will put another beam. Um, so this one is okay, angle okay, angle to, so after you finish all the beam, so for the radiation treatment radius dose you can apply here. So some of them just apply the fractional dose. I think I just as based on the different most of for the one fraction for the esophageal cancer, I think between the 1.6 to 2 gray per fraction. So I think I will just put the 2 gray. And those engine, you know, the difference between the commercially treatment planning system in radio in hospital and the free software is based their algorithm, their those engine. Some of them use collapse cone, cone beam, and some of them use the pencil beam. Uh, but for this, they use the for this 3D slicer, they use the Mox random, and this is they have a lot of limitation for this because some beam energy they can set the beam energy and some of another. So for next is just choose the Mox random and calculate those. We will calculate the those to the and make sure you uh, will show the make sure you choose the output dose volume to the total dose. This is after the dose calculation. Actually, this is not the isodose. Actually, this is the representation of the from the Mox random uh, Mox random dose calculation. So for the next part, I think do you have any question for until here?
Fahmi, so okay, what should we consider or take into account when doing the angle beam?
Uh, First, the angle beam usually to avoid the OAR. Some of them based on the protocol is the for the case. For example, this is and take this from the uh, ICRP. Some of them they use the two parallel opposite beam and the two beam from this angle to avoid the dose to the excess dose to the heart. So the you have to consider the protocol and some of the OAR dose to OAR. And for this part also some of them you can you can't shape the beam to the using the MLC because this beam also just in based on the box field. So this is the other limitation of this extension and the digitizer. They have still in development for the MIC configuration, but I don't know when they release for the kind of features. Yeah, you have to take consideration based on the protocol and the case and the OER. Those um, any question? Any question?
Yeah, one, is there a margin of the beam to PTV, or you just eyeball it?
Yes, I just make sure the beam is covered with the PTV. After you have to, maybe you should maybe after the you see the analysis of DVH, you can edit back the beam to decrease the beam, or because DVH is important to see the what kind the dose is achieved, the target is achieved with the dose achieved with, to the target volume. So first make sure the beam cover the PTV. Okay. Question. In, we move to the next analysis. After the you calculate to dose, you wish we store the dose image in uh, the total dose volume. We should if you see the data module, we show you what kind of dose you have. This is a total dose image is we call the dose image. This is in dose image is important if you know want to know the dose in specific fermentation organ. So we will use this total dose volume to know to the know for the next step. And after this, go to the radiography and the dose volume histogram. Um, okay, I think better you every time you done something, just play safe, because in my previous experience using the 3D slicer, I load a lot of those images inside the 3D slicer. Some I'm using some I think some of during my experience I even using up to 10 gigabyte of RAM for the for the slicer only. And I use the remote workstation better. This is more powerful than my laptop. Actually, this I remote from the workstation. So um, because of disaster in my okay, I think I better use this kind workstation. Uh, when you enter the module DBH, we show you this interface. So for the parameter it will automatically create the dose volume histogram volume for you. And for dose volume, you choose the total dose, and the segmentation is we want to know to the volume dose to each segmentation volume. So you just click the segmentation. So you can choose the individual such as by team. Better you just show those. Okay. For the next is just this one is to compute all the DVH based on the um um actually this is this structure I removed from the work session. I think loading for the okay. After you mm, uh, okay, for this okay, this is what the DVH look like. I mean the this is the dose accumulation in each organ. See the we show you how much the dose in the um, body, lungs, liver, all the bodily segment. So if you want to show the all just show all the DVH, we will display all the graph based on the DVH. For the next is want to know the some of the how to analyze the DVH. They have a lot of protocol. I mean the reference those some of the RTOG Quebec. I think I will use the RTOG. I, the RTOG based on the how much dose limit in each organ that allow. For example, the lung, liver, heart. So you can refer the dose limit for the uh, different what you want. So for the next is if you want, we check the the dose we the beam we create pass. I mean we can be acceptable. We use the the D99 or D55. So so this is important. Okay. So you can check this again. V I mean D55 or D99. If all the pass will show the 100%, because of the I think because of the limitation of the DOS engine, some of the DOS doesn't 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 show the correct DOS, which will calculate again. Okay, this one. Mm, show all the DVH. This part is you can refer all the protocol based on the each case you do. I think you get the rough idea of the treatment planning system before you know you use the real commercial treatment planning system in the hospital. So from the load of the patient image data to the uh, contouring segmentation, and the next beam planning, insert the beam, uh, and the those calculation based on the algorithm, uh, and the next is DVH analysis, and you can see the dose accumulation, see the is it acceptable the dose accumulation to the OAR. Um, mm, so for the some of the synthesizer, one so this is the DVH. Can click here to show the all the graph to the DVH only. So you can analyze based on the so uh so I think this one is for the 1990 IMV 94. I think we have to check back with the protocol. Is it acceptable, and you analyze the DVH. So any question before I move to the isodose module? Include the isodose volume inside the on.
For me, there is one question. Does this calculation take into account electron density of the CT images?
This one before this dose engine actually I could not find any documentation this is for this dose engine, because this is not available anymore. So I could not find any documentation. I think this dose engine based on the CT config unit, and some of, because this is only C++ simple dose engine, so I can't give any comment about it. Some of them they have uh, some extension you can include also the GS Monte Carlo simulation. So I think Monte Carlo simulation is more accurate than those engine, those mock engines. So this is the one of the limitation of this Slicer RT. So I can give anything comment about this. But you know the rough idea of this the game planning. Um, any question? Okay, I think I will move to the ISODOS. This is ISODOS is the map or just region to show you uh, how much the dose for the each value dose you specifically request. For example, 5 gray up to the 30 gray. But this one is you should be aware that the maximum dose is 5 gray, right? So the ISO dose should not be more than 5 gray. So I think not 5 gray, 8 gray. So because some of the commercial TPS just automatically fill for you. So for this one, you have to fill by yourself and choose the dose volume based on total dose. Then create how much the ISO dose level you want and just generate the ISO dose. In this, bear in mind that this is just free software. I think some of the commercial TPS in hospital they have a lot more advanced features, like some of them you can get auto contouring. Some of them also include the more advanced beam calculation. Some of them also include the Monte Carlo simulation, and they have also used some of machine learning. Okay. think, um, I have to increase, uh, so for this one, you have to make sure the just guess what kind, what those will be sure. So some of them so the five um here's um so for this one uh okay, this is the ISO dose and like on the dose volume. So you can disable the segmentation. You can hide the segmentation. So this is what the ISO dose. The ISO dose is what value of the dose inside the for the specific thing. Yeah, I think that's for they have a lot of module. You can log for example from the you those calculation you calculate the those calculation from the TPS commercial TPS, and you just import the dose volume outside, and you if you want to compare the dose from the day one treatment with the second day treatment, yes, you can use those comparison to know what the difference between those module or those treatment for each that day. Some of them you can compare the DVH. This comparison you have to look more than two more than one dose volume. Um, any question for the
There is one question. Is there any additional functions such as weight, bolus?
uh, for the I think they have no, they don't have a function for this. And some of the gantry no which that's the limitation. They have this one MSc position, but in the still not enable the MSc MSc shape bin. Uh, yeah. Any question?
So from your side, this it from me? Okay. Any questions from the participant?
I think you use for this introduction session. I think you should know the rough idea from the beginning and to the last. First to load the image, contouring. That is beam planning and DVH analysis and some ISO those create um, question.
I think some of them is actually arrived a bit late. Can you just show again how did you install the RT extension after you have installed 3D Slicer?
So, after after you open the after you open the 3D slicer, you have to go to the slicer module. This is you have to click this one extension. So they have a lot of extension you just can discover. For this one, you just search the slicer RT, and click the slicer RT. Just click install here. For me, I already installed, so just click install. After the finish, you need to restart the 3D slicer to make sure the 3D slicer load that module on the slicer RT. You can go to the slicer RT website, search the slicer RT, and you can go to the documentation if you want to read more about this about the module or the module. So, even they also have some tutorial. You can get some of the tutorial on this. So one of the function of the slicer RT, they also include the image guided radiation therapy. In this example, I think they load different day the treatment. For example, day 1 and day 2, they want to compare the dose between this treatment, and they also show you how to use the uh, radiation therapy based on the image guided. So in this one, you have to uh, register the dose image based on the actual CT image. So you can explore this one. You can get the data set, and they also include the slide. So just read and you can do by yourself. So they have some of them also include the beam therapy using the EGS. So this one is another thing. Um, um, hmm, any question then? Hmm.
So far, I did not see any other question from others. I would like to thank Fahmi for his time. I know that he's busy with his PhD, but he still take his time to actually at least introduce us to the system itself. I know there is a lot of limitation compared to, of course, the so-called expensive treatment planning itself. So this is a free software, so I believe that there will be a lot of limitation, but still, to me, it's still useful for you to play around with it before you go to the commercial CPS system. Before we end, can we have a photo session together with all the participants? Can you on the videos, if you are able to on the videos, so that we can take a photo together before we end the session? I can see some alumni as well. Good to see all of you here. Oh, Farah dekat Biophysics Lab. How about the others? Okay. Is that all? Aimi, I'm not so sure your video is on, but I think maybe there's a sticker on the camera, so we cannot see your face. All right. I'm not so sure about the others. So maybe we can have a few shots. Okay, ready? Smile. 1, 2, 3. All right. Wait. Okay. I think the picture is okay. Wait. Let's have another one. I can see a new. Okay, ready? One more time. 1, 2, 3. Smile. All right. Thank you, everyone, for your participation. So hopefully you will make use of this software. So if you feel like your PC cannot actually accommodate that, we have the PC in our lab. Install this everything. Again? Okay. So we have okay, those from Green Girls.
Yeah.
Perhaps we will request you to do a one-day treatment planning using your, I'm not so sure if using Monaco or other system for us. All right, okay, ready? 1, 2, 3. All right.
Everyone.
Okay. Thank you, everyone. Okay. Bye bye. See ya.